Hello, all you cool cats and kittens. So yeah, I did jump on the Tiger King bandwagon and watched all that stuff. So, it's good, 5 hours of entertainment. Alrighty, so we are finishing the chapter or the unit. This is the last unit, or the last section for our unit. Then I will hand out the review tomorrow, and I am not taking that review for a grade. So you will have a test on Monday and Tuesday of next week. All right, and that will finish up that unit, and then we just have the one unit left. All right, so finishing up the unit, we are finishing up with radical inequalities. So again, inequalities mean that there are several answers that will work. All right, so for instance, when I say you have x is less than 3, there are a lot of numbers, actually an infinite amount of numbers that will work for that. So solutions to that would be 2, 0, negative 100, negative 1 million. Okay, so these are all solutions that would work with this inequality. All right, and that's what we're going to do with this radical inequalities for today. Okay, but when we're dealing with radicals, there's two issues that come up. First of all, we want to be able to find the values of x that will make this whole quantity less than or equal to 8. But then there's the issue of, oh, that's my husband's phone. Hold on. All right, if you heard that, that was a Star Wars theme. Yeah, so that's his ringtone. Anywho, okay, back to this. Now, the 5x minus 10, there are some issues with the 5x minus 10 because we cannot have negatives underneath this radical. So not only do we want to pick values that x will make this whole thing less than or equal to 8, but we also need to worry about the numbers that are going to make this become a negative. Okay, so there's going to be two steps that are going to, or there's the first step to this is going to be to solve the radicand. All right, now we need the radicand, which is the 5x minus 10. First of all, that has to be greater than or equal to 0. Okay, it can equal 0, but it definitely cannot be less than 0. So we want to figure out what number will make it a 0 or greater than 0. So we're going to add 10 to both sides. And we're going to divide by 5 to get 2. So divide by 5, divide by 5. So far our x has to be greater than or equal to 2. That's one thing that has to occur. Okay, now we want to figure out, so I figured out what numbers I need in order to make this be positive. Well, then the next step is to figure out what numbers that not only will be positive from the radicand, but then also work for this entire problem. All right, so the next step is to solve the inequality as we would the equation. All right, so I'm going to take out the inequality. So I have 3 square root of 5x minus 10, and just make that equals 8. All right, so I'm going to subtract my 3, so I get the square root of 5x minus 10 because we know that we need to isolate the radical. I get 5. I'm going to square both sides. So I get 5x minus 10 equals 25. Add 10. So 5x equals 35. And then divide by 5. So x equals 7. Okay, so what does that mean? Well, basically what I want to do is take these two numbers, and now we're going to set it on a number line to determine the exact solution for this. All right, so test the points surrounding the answers on the number line. Now, I did say that my x values has to be greater than 2, but we're just going to use this test point to come up with a total different answer for this. So I'm putting my two numbers on the number line, 2 and 7. And what we need to do is we need to test points in each of these areas. Okay, so we're going to do 3 test points to see which ones will actually work. Now, I do know that the x has to be greater than 2, so I can kind of knock that out, but I'll just show you how we're going to use that test point. So in my original equation, I'm going to test a number that's less than 2, and we will see that it's not going to work. So I would test, say, 1. And that gives me 3 plus -5 equals 8. And right there, that knocks that out. So this does not work. All right, let's test a number that's in between 2 and 7. So what's a number in between 2 and 7? Who said 5? All right, good. We're going to go with that one then. Is less than or equal to 8. I should have made these less thans or equal to. Okay, so I get 3 plus 25 minus 10 is 15, less than or equal to 8. So over here, the square root of 15 is about 4.1. No, it's not. It's not 4.1. It's 3.9. Okay, so the square root of 15 is about 3.9. So I get 6.9 is less than or equal to 8. That checks out. Okay, so I'm going to use the numbers in between here. I'm going to do my last little check here. So my last check, I'm going to pick a number that's greater than 7. So 3 plus 5 times 8 minus 10 is less than or equal to 8. So 3 plus the square root of 30, less than or equal to 8. The square root of 30 is about 5.5-ish. So we get 8.5 is less than or equal to 8. That does not work. So, okay, so what tells me is that the only numbers that will work in that inequality that, first of all, allow for us to have positive numbers, but then also overall being that it's less than or equal to 8, are going to fall between 2 and 7. So we're going to write it as an inequality. So what that means is that the x has to be greater than or equal to the 2, but then less than or equal to the 7. Greater than or equal to the 2 and less than or equal to 7. And that's our answer. So that's the final answer for that. Okay, so I'm doing another example. And then you guys have homework, which will be 3 problems to do at the bottom of the page here. Okay, so step 1. Take the radicand. And I know that that has to be greater than or equal to 0. So 2x plus, oops, so I'm going to subtract the 14. Divide by 2. So I know that the x has to be greater than or equal to -7. All right, step 2. Solve it as if it were an equation. Oops, forgot my radical there. So square root of 2x plus 14 equals 10. Square both sides. 2x plus 14 equals 100. Subtract 14, I get 86. Divide by 2, I get 43. All right, so x has to be, so I know that on my number line now, I need numbers to check that fall within these 3 places. So I need, well, once again, I know I need numbers that are greater than or equal to -7. Okay, so I do know that. But I need to check, do the numbers that I want fall between -7 and 43, or do they maybe fall past the 43 in this area? Okay, hopefully it makes sense to you that I know, again, that my x values have to be greater than or equal to -7. This is not going to work. So if I pick numbers that are in this orange area, they will give me a negative in this radical. Okay, if you want, you can plug it in and check, but anything less than that -7 will not work. All right, so let's pick a number between -7 and 43. All right, my personal preference would be to pick a 0, because that's easy to use, so I pick a 0. Okay, so I'm going to get the square root of 14. Square root of 14 is about, I'm just again guesstimating, 3.8. And I get -6 minus 6 is greater than or equal to 4. Okay, so I'm going to get a -2.2 is greater than or equal to 4. That is not true. So you know what? This doesn't work either. So more than likely, what is going to work are values that are greater than 43. So we will check that. So pick a number that's greater than 43. We can go with 44. Run out of room there. All right, so I get 88. 88 plus 14 is 102. Minus 6 greater than or equal to 4. That's about 10.1. Minus 6 is greater than or equal to 4. So I get 4.1 is greater than or equal to 4. That checks out. So my only solution is in between this area here. So my final answer is all the x values have to be greater than or equal to 43. And the reason I knew it was greater than or equal to, I'm just going off of this symbol here. Typically your answers follow that symbol. So if it's or equal to, it's or equal to there as well. Okay, so again, it's not always going to be just in the middle. You have to check your work. Okay, you have to check those points. So in this previous problem up here, once again, I checked the points in between, so I wanted numbers in between 2 and 7. Well, the numbers in between -7 and 43 didn't work. The only numbers that worked were greater than 43. All right, so here's your Edpuzzle problems. I do have 3 of them today, and I will try really hard not to make a mistake. Sorry about that yesterday, if you did your problems yesterday. All righty, so I'm going to pause it really fast. So you should have completed problem number 1 by now on the Edpuzzle. Okay, so that's all. Whoops, not using a highlighter there. All right, let's get rid of that. Okay, so on the Edpuzzle, you should have already done that one. Okay, so now the next question is to solve number 2. All right, so solving number 2. You're going to do that right now. Okay, so you've solved number 2. Now it's time to solve number 3 and write your answers down on number 3. Okay, so you should have submitted your answers by this point, and now I will go through the answer key and show you again how to work out those problems. So hopefully you got them correct. Okay, so here we go with problem number 1. So at this point, if you don't really want to check your answers at this point, you may shut off this video and you are done for the day. All right, so step 1. Step 1, we are solving for the radicand. So 5x minus 2 is greater than or equal to 0. So 5x is greater than or equal to 2. And then x is equal to greater than or equal to 2/5. Okay, so we do know that, again, once again on the number line, we know that we're going to have a value greater than or equal to 2/5. Okay, now we're going to solve it as if it just were an equation. Subtract 1. Get 3. Square both sides. Add 2. And I end up with x equals 11/5. Okay, so now we're going to check those 2 solutions, 2/5 and 11/5. So I want numbers that are less than, numbers that are less than, but once again, this one, I know that my numbers have to be greater than or equal to 2/5, so that one's out. So basically, this guy's out. You know, sometimes you do get numbers down here. Maybe one of these 2 will give us that, but typically that doesn't work. All right, a number that's between 2/5 and 11/5 would be 2. All right, because 11/5 is 2.2, so 2 works. So we check 2 in our solution. 1 plus 5 times 2 minus 2 is equal to 4, or is greater than or greater than 4. So I get 1 plus, that's 10 minus 2 is 8, greater than or equal to 4, or just greater than, sorry. Greater than, there we go, whoops, greater than. Okay, so the square root of 8 is approximately 2.9-ish, somewhere in there. So 2.8. So we have 1 plus 2.8 is greater than 4. That's 3.8. That does not work. Okay, so we check a number that's greater than 11/5, which would be, which would be, say, 5. So we check 5 in there. 1 plus 5 times 5 minus 2, greater than 4. 1 plus 25 minus 2 is 23, greater than 4. So 1 plus, that's like 4.7 7-ish. Okay, so you do get 5.7. So this works. So the solution, x is greater than 5. Or, excuse me, x is greater than 11/5. X is greater than 11/5. X is greater than 11/5. All right, number 2 here. Radicand, 3x plus 9 has to be greater than or equal to 0. 3x has to be greater than -3. So x has to be greater than or equal to -1. Solve it now. 3x minus 9 minus 2 equals 7. 3x minus 9 equals 9. Square both sides. Get 81. 81 plus 9 is 90. So 3x equals, oops, x equals 30. I've said oops a lot, and I really apologize about that. All right, so x equals 30. So on our number line, -1 and 30 are where the numbers we're checking to see where they fall in between there. Let's pick this pretty fuchsia color, purple-ish, and go back to green. Okay, so we're checking in those values. All right, so step 1, if we check these again, I would get negatives. Those are not going to work. So anything less than -1 will not work. How about a number between -1 and 30? So I like 0. 0 is easy to use. So we plug that in. 3 times 0 plus 9 minus 2 is less than 7. So square root of 9 is 3. 3 minus 2 is 1. 1 is less than 7. That checks out. So part of the solution will be here. Okay, if we check 30, maybe you made the assumption already 30 is not going to work because I need numbers that are less than 7. So if you pick, say, like 31, I'll erase this part over here. So 3 times 31 plus 9 minus 2 is less than 7. So 31 times 3 is 93 plus 9 is 102. So I get about 10.2-ish minus 2. That's going to give me 8.2. That does not work. Okay, so the last thing to do is write the solution. Your x is in between these two numbers. Based off of this inequality, it has to be greater than -1 and less than 30. All right, there's your solution for number 2. And last but not least is the third one. Okay, so hopefully you have that written down. I'm going to get rid of this, give myself some room. Get rid of some of this, because you can rewind it. That's a good thing about these videos. Give myself some room there. All right. So 6x plus 1 has to be greater than or equal to 0. So 6x has to be greater than or equal to 1. So x has to be greater than or equal to a -1/6. Okay, now we solve it like normal. -3 plus square root of 6x plus 1 is equal to 4. So square root of 6x plus 1 equals 7. 6x plus 1 equals 49. 6x equals 48. X equals 8. Okay, so on my number line, I have a -1/6 and I have 8. But for the third time, fourth, fifth time now in a row, I know that I can't have numbers that are less than -6, because if I did, I would get negatives under here. So none of those numbers work. I think pretty much the only time it's going to work is if these happen to be negative in here. So, but I didn't do any examples like that. All right, so let's pick a number between -1/6 and 8. Again, I always like 0 if I can use it. So -3 plus 6 times 0 plus 1. -3 plus the square root of 1 is 1 is greater than 4. This is a -2. -2 is not greater than 4, so that doesn't work. So more than likely my answer is going to be here, but let's check. -3 plus 6 times 9 plus 1 is greater than 4. -3 plus, that's 54, plus 1. The square root of 55 is 7. We'll go with 7.5-ish. Okay, so I do get 4.5 is greater than 4. That works. This is my answer. So how do I need to write this in an inequality form? X is greater than 8. That is my final answer. X is greater than 8. All right. Have a good day, guys, and I will talk to you later.